So hello everyone, and today we'll be seeing one of the problem known as two sum pair with a given sum. So what does it say? That we are given an array of positive integers and another integer which is a target. Now we need to find whether it exists within an array two distinct indices such that the sum of these elements is equal to target or not. So for 16 we have two indices as 6 and 10, so we can say yes, it exists. For 11 we cannot say because any of the two indices don't give it. Neither we can say about the example number 3 because there is only one number. At least two we need, right? So how do we solve this problem? This problem can be solved with multiple ways, and we are going to discuss all of them once. So way number 1. So this is a brute force which will go ahead and check each I and j. So what I'll do is I'll check index 1, so that this number with the rest of 4, 45, 6, 10 and so on. You get the drill. Next time I'll take 4 with 45, 6, 10 all, 45 with 6, 10 all. Once I get to 6, then I'll get to 10, and then I'll know, yeah, 6 and 10 works, so I'll just return true. Within the sorry, so within the worst case scenario, my time complexity goes ahead with O of n into n, because for each n elements we are traversing n times. So that is how it's going to work, and with a space complexity of O of 1, because no additional space we are using. How can we optimize this? We can do one thing here, is we can use what do we say is binary search. So with binary search we are going to head with sorting the array. First of all, this array doesn't seem to be sorted, but once we did, it would look something like this, where we have 1, 4, then we have 6, 8, 10 and then 45. Also do mention which kind of sorting algorithm have I used to sort this. I have just inserted one by one elements, and let me know which kind of sorting algorithm it was. So once it is sorted, I'm good to check whether we have 45% or not. How do I check it? The question is very simple. I'll go ahead with 1 as number. So iterator would go from 0 to n minus 1, and for each number I will binary search upon the array. Obviously this will be a log n operation, and this is a log n operation, and this is O of n operation. So it would be O of n log n operation within time complexity, and obviously for space complexity we are not using any extra space, so it's O of 1. This works, but can we do better than this? So the question arises, why we are needing two iterations, or why we are needing a binary search. So we need two iterations because we wanted to check for, let's suppose for 6, does there any value exist such as 10? If yes, then we are good to go. So we can leverage a fact of checking quickly. So whensoever we need to check whether some elements exist or not, we can leverage the value of sets. So using set we can do a very good thing, like suppose we need to find target as, let's suppose 16, and we have current value which is 10. So check within set if there exists 6 or not. So you got the drill. So if 6 exists, then we are good to say that yeah, we can get the required output, else no. So obviously checking time complexity for this approach is, if you are using with hash set, we are only with O of n, and checking with space complexity, it uses O of n. Sure, we leveraged the space complexity, so the time complexity could be reduced. So far so good. Can we go ahead and code this one? So let's do it. What I'll do is, first of all, I'll create a set of integer, and I'll call it just set new hash set, and for each element int I within array, I'll check int I need to find it, right? So exist element, for now I'll say this is equal to target minus I, because why not? We need to check the element exist, and in such a way that element exist plus I is equal to target, and moving I on right hand side, it will be a formula something like this. So this thing is very simple. So I'll go ahead, if set dot contains exist element, then I'll go ahead return true, else I'll just go ahead and put set dot add the I value, and this will go ahead one by one checking or adding one by one elements, and if the array ends, we return false, because no such condition satisfies this. Let's submit this. These are the few solutions, like 3 as of now. You can, instead of taking set, you can use a hash set where you keep a count. Hash set gives you a very good thing of having the index. Suppose in this example, if you were asked to give an index as well, if you find 2 integers, give an index of it. In that case, a very good solution would be hash set. Here set mappings would be based upon the value to index, and so on. And if you are confused that, hey, if the index can be repeated, then okay, obviously it can be repeated, so in that case you can go ahead with list. Of course you won't require this, because it might at most repeat n number of times, but you need only 2 times. So any of the index you can go ahead and keep, unless and until it's specified the maximum minimum kind of indexings. It's taking longer than usual, and simultaneously we can see that it's compiled. So this was all about it. This was a part of multiple interviews, I guess. There are multiple company tags over here. The topic tags belongs to data structure, hash, and arrays. So if you wanted to know more about arrays or hashing, click the video on your right, and I'll see you in the next one.